name is Josh Coon, and I'm a professor of biomolecular chemistry at the University of Wisconsin-Madison, and also an investigator at the Morgridge Institute for Research. My laboratory works on mass spectrometer technology development, and in particular, how we can apply this very exciting technology to solve biological problems, ranging from protein sequencing to lipid analysis and to discovering metabolites in a variety of systems. So some of the major limitations facing small molecule, and in particular lipidomic analysis, are twofold. First, that when you electrospray a lipid, and this is for most lipids, you actually get more than one mass to charge peak relative to that lipid. And that's because they take many adducts, different adducts, they can often dimerize. And this can actually limit the ability to detect and sample low-level lipids because you're spending all your time on the multiple versions of the high-level ones. So that's one big problem. The second problem is the ability to fully characterize and identify a lipid right down to the position of the double bond on the fatty acid tails. Now that can be really challenging, and it can limit our ability to accurately quantify and even detect which lipids are present, because often they have positional isomers and there are a variety of differences that you can't fully tease out. So these are two big areas that have been an issue for our field for many years, and it's really exciting to see some new technology coming that directly addresses these problems. So we've been really excited to be working with Thermo Fisher Scientific on some new technology that's going to be incorporated in the Orbitrap IQX to tackle these major issues facing small molecule work and especially lipidomics. So these technologies really revolve around the ability to do intelligent data acquisition. So first, for the problem of having multiple species in your MS1 for one lipid compound, it's going to be tackled by using intelligent acquisition that allows us to determine which are adducts, which are dimers, and which one would be the most advantageous peak to subject to MS2, the most likely to give you an identification, while ignoring the rest so that you can then have bandwidth to sample lower level species. Secondly, this system is going to be outfitted with the ability to do real-time spectral library searching. And that enables us to take that MS2 and to compare it to the library and to immediately know whether we've fully characterized the molecule. And if we haven't, we can harness the power of the ion traps to perform MS to the N characterization on all the different product ions so that we can fully elucidate that structure. It's a really exciting time to be in lipidomics, and our hope is that with these new technologies, we'll be able to not only get deeper into the lipidome, but to characterize it much better, and that's going to afford us better biological insights and higher quality quantitative data. So one of the exciting things to emerge out of this collaborative project with Thermo Fisher Scientific is the ability to measure small molecules on a Tribrid system. Sort of really came aware during this project of the power of the ion trap and the increased sensitivity and the MSN capability. We feel like it's going to offer a lot of opportunity to improve the depth of the metabolome and lipidome sampling. But another nice thing, as compared to the Tribrids we had been developing this work on, is that with the launch of the Orbitrap IQX, we now get a Tribrid system that has been really customized and dialed in to support this work. Not just the ion traps and the intelligent acquisition tools, but all the way from the source through the front-end optics are really tuned up and geared for small molecule transmission, which we find is really helpful in getting the best signals and getting the best quality data. So right now, we have in my own lab several applied lipidomics projects spanning from looking at the lipidomic signatures of Alzheimer's disease and cerebral spinal fluid plasma, to looking at the lipidome profiles in plasma of COVID-infected people, very severe versus not severe versus COVID long haulers, and trying to understand what are the signatures, lipidomics speaking, of those diseases and many others, And one of the common threads through those projects and in the field is that the majority of the lipid signatures that we identify go unidentified. And we know that many of these, like the things we can identify, do correlate with the condition, the disease. And so what I'm really excited about this real-time search technology that we've collaborated with Thermo Fisher Scientific to develop and now is going to be present in this Orbitrap IQX is that this system is going to help unlock many of those unidentified compounds that we already can see and we know are important to human health and disease, but we just don't know what they are. And I think that is super exciting for the field, and it's super exciting for human health and what the promise of mass spectrometry holds to help unlock some of these long-lasting questions.